Assalamualaikum and salam sejahtera. Well, in this video, I would like to talk about how are we going to apply another one more module which has been provided in SolidWorks, which is known as SolidWorks CAM. Okay, let's get started. So, guys, in order to uh, apply the SolidWorks CAMs, we need to have a SolidWorks CAM toolbar. All right. So since in my case I still do not have yet any SolidWorks CAM toolbar, therefore I need to call out to add in that particular of toolbar uh, in my toolbar sections over here. So what I need to do is that I just need to go to tools. This one I'm going to call out the SolidWorks CAM toolbar, right? So I need to go to tools and go to add-ins, all right? Click this one, and you're going to have add-ins dialog box. If you scroll down here, you can see that under SolidWorks add-ins, there's a SolidWorks CAM 2019. So you just need to check both of these box here. Okay, check both of this box, and then just click OK. All right, now guys, let's say I'm going to create a certain part or certain simple component. Okay, for your information as well, that before we go further, in this course, I just will touch only the basic milling operation, okay, in order to create a certain part or a certain simple component, all right? So first of all, before we can go to the SolidWorks CAM simulation, all right, analysis or SolidWorks CAM simulation activities, we need to create a part, a 3D part, a 3D solid parts or a 3D solid components. Okay, as you can see over here, once after we already add instance now, the SolidWorks CAM toolbar will appear like this. Okay, so as you can see over here, okay, even though if you refer to our manager design tree over here, there's another additional three more tabs. Okay, for the time being, our tab, we only have four tabs or five tabs altogether, one, two, three, four, five. But once when we uh, enable or activate the SolidWorks CAM toolbar, there will be additional three more tabs, which are known as SolidWorks CAM Feature Tree, SolidWorks CAM Operation Tree, as well as SolidWorks CAM Tool Tree. All right, so we will go to all of this later on. All right. So, as I already mentioned to you previously that before we go to the SolidWorks CAM operation or simulation activities, we need to create a 3D solid modeling, all right? So I'm going to create a simple 3D solid modeling. And so I'm going to pick top plane as my sketch plane. And then I'm going to pick the center rectangle. And I'm going to indicate a dimension here. Let's say 80 mm, whereas the length for this one, let's say I'm going to make it 100 mm, right? You can indicate any value for both of these length as well as the width, right? So I'm going to extrude this particular of sketch with, let's say, 20 mm, the height of this particular sketch, all right, which we have created just now. So okay, it should be look like this, and then I'm going to apply as well the fillet at all these four corners. So I'm going to click fillet over here, and I'm going to make sure that it should be a constant size fillet. And okay, let's say I'm going to maintain with 10 mm radius. So I'm going to pick this one, two, three, and four. There you are, right? Okay, then I'm going to create another one more here, features. I'm going to cut a bit. So I'm going to pick this surface as my sketch plane, And then I'm going to pick again my center rectangle. I'm going to start at this origin, and I'm going to indicate the dimensions, whereby the distance from here to here, let's say 15, all right. And again from here to here, let's say 15. Guys, again, I would like to inform here that you may add or you may key in any dimensions. Okay, the value of dimensions, okay, is up to you, right? So this is only an examples, right? So now I'm going to extrude cut this particular of sketch, my second sketch. I'm going to extrude it cut, and let's see, I'm going to extrude it about 10 mm. Okay, okay, so it means that it's a step down 10 mm, and just click OK. And again, I'm going to apply my fillet features, my fillet commands, and with the constant size fillet, and again I'm going to maintain it with 10 mm, right? So I'm going to pick here, pick all these four edges, all four corners here. There you are. Okay, I think it seems like okay for me. Once after confirm, I just need to click OK. Now, guys, all right. So once I've recreated this particular of simple 3D solid modeling part, I'm going to save this file. Okay, definitely I'm going to save this file. So I'm going to go to File, Save As, and I'm going to create another one file. Okay, one folder for this particular of SolidWorks CAM tutorial. So I've already created one. So I'm going to go to D, and I'm going to go to FKM. Okay, wait, where is it? Okay, CAM tutorial over here. So I've already created a folder here, and I'm going to rename it as CAM Part 1, right? CAM Part 1. So this is my 3D solid modeling part. Okay, in order for me to proceed with our SolidWorks CAM simulation activities. So once I've already named it as CAM Part 1, so I just simply save it. Now, it's time for us to proceed with our SolidWorks CAMs, and as I did mention to you previously that I just in our course we're just going to focus on the most basic, okay, milling CNC milling operations. So the first thing that you need to do is that you need to go to the SolidWorks CAM Feature 3 tab, this one, which is this one. We do have three, as I mentioned to you just now. We just need to, for the time being, at the first or the preliminary stage, at the first stage, we need to focus on the first tab, which is this one, okay? All right. So first of all, we need to define, before we go further, okay, we need to define our milling operation machines. Okay, so what you need to do is that you just need to go to the machine milling over here, and you need to go to we need to define the machine first. Okay, so go to SolidWorks CAM NC Manager over here, right click, and then go to define machine. All right. Okay, and this particular off dialog box will appear. So as I mentioned to you just now, that we're going to focus only on the basic type of CNC milling operation. Therefore, I'm just going to pick this one, mill matrix, and then go to select. Just let it become as a, you can have light duty as well, but I just the machine duty, so I just leave it as a default like this. So click this mill matrix and then select. All right. Then next step is tool creep. Tool creep is some sort like a station in order uh, to assign few tools in order to proceed with the CNC milling operations later on. All right. So as you can see over here, this is empty. This tool creep is still empty. Just tool stations. Okay. For the tool creep 2, which is in matrix, okay, units. As you can see over here, we do have 20 number of stations. Okay, all right. So it means that we can allocate 20 different types of tools. okay, cutting tools. However, for our case, if we go to tool creep tool matrix, as you can see over here, okay, we only they already only the SolidWorks only provided for us only 12 types of cutting tools. So it means that we still can, apply for another eight more types. However, we just leave all this as a default, right? So uh, just click tool creep 2 and then don't forget to click select button. All right, now we go to the post processor, the next step, which is the tab of post processor. So go to the processor. Well, guys, post processor is actually one of the main features in CNC machines, all right? Whereby the type of post processor actually are depending on the types of or brand of the CNC machines. Okay, the CNC machines brand. As we can see over here, we do have a few types of post processor like Gfano. Okay, we do have the Centurion. Okay, we do have Dialog. However, uh, for example, for our case, okay, we just choose M3 axis tutorial, this one, all right? So click this one and don't forget to select, to choose or to pick the select button over here. All right, so this is the summarize, okay, summary which summarize the parameters of this particular post processor, okay? And then for posting setup rotary axis as well as tilt axis, we just leave it as a default. All right, so once after we already defined our machines, we just need to click OK. Now it's time for us to extract the machinable features. Okay, so just click here. All right, and then in this particular case, the next thing that you need to do is that we're going to edit the stock. Okay, we need to edit the stock. So go to stock here. Okay, this one we already done just now. Okay, so stock manager. We go to the stock manager here. Click the stock manager. Right click and then edit definition. Okay, now guys, stock is some sort like a raw material before we uh, create the original particular of 3D solid model part by using the CNC milling operation or CNC milling activities. Okay, so it means that it's our original part. So or original raw material. So in this particular case, you can pick any type of materials that you're going to apply. So in this case, we do have multiple choices in order to pick the type of materials. However, in this particular case, I'm going to maintain with 60616, which is an aluminum alloy type. So if you pick this one, let's say 3168, it is a stainless steel. It's a stainless steel material types, and let's say you go to 8600, it's low carbon alloy steel, but as I mentioned to just now that I'm going to stick with this default material, which is 6061T6. It is a type of aluminum alloys materials, and the stock type just let it be a bounding box and let this coordinate system as origin as well. Okay, just set maintain it as a default. And now uh, as you can see over here, the orange color, okay, the orange color is our stock, okay, representing our stock. So I'm going to have an extra uh, materials or extra stocks, okay. So by adding here, let's say I'm going to make it 5 mm at x-axis, okay, x positive as well as x negative. So I'm going to have like that. So it means that we do have an additional x or extra material or stocks like this. Okay, and then y let's I'm going just to would like to have only on the top portions like that. Okay, and then z I'm going to have both as well. It's not necessary to have 5 mm. You can have 3 mm as well. Should be no problem, 3 or 2 mm. But in my case, I would like to indicate it as a 5 mm. So it means that we have another 5 mm extra here, 5 mm extra here, side by side over here, as well as on at the top over here. But the bottom I just leave it without any extra materials. Okay, now, so once after everything is okay, once we already selected everything, just need to click OK here. Okay. Now, we need to go to the next step. Okay. Before that, allow me to check the mill part setup first. Okay. Go to the mill setup. Okay. Go again. Still under stock manager, right click, then go to mill part setup, and in this particular case, instead of using the front plane, we need to choose the top surface like this. This is the most top surface, okay, for this particular part. So choose this particular surface, right? So that the tools, okay, should be vertically or perpendicular to this particular office. Okay, this is actually the cutting directions. Okay, the cutting directions. All right, now, so once after we already choose this face, just click OK. The next step, we need to go to coordinate system over here, right click, and then we go to edit definition. So uh, so in this particular case, we just for fixture coordinate system, so we need to locate or define our coordinate for our CNC milling operations. So let this method as user define, and the origin we're going to pick stock bounding box vertex, okay, which we already created just now with extra additional 5 mm for each of the sides. All right, now the axis, as we let's say for this particular stock bounding vertex, once after we already click this one, let's say we would like to pick it over here at this particular of as you can see over here, we do have a small dotted a gray color, okay, at a certain area or at a certain point. However, for our case, let's say I'm going to pick it somewhere around here as our coordinate system, okay, fixture coordinate system. So I'm going to pick this particular point, and then my axis should be at this side. So click this one, and I'm going to pick this particular of line here, each here. You can pick either here or here, should be no problem, okay, or here as well, as long as it's at this particular area. So I just need to click this one, X, there you are, X, then Y, I'm going to pick here, or you can pick here as well, or also this each, so that is aligned with the y directions or y axis. Same to go with just now the x axis. So I'm going to put it over here, because since it's facing at this uh, uh, this side, so we need to reverse it. So just click this one like that, and Z should be upwards like that. Okay, so once after, so it means that we no need to do anything if the Z facing upwards. If let's say if the Z direction facing downwards, so we need to reverse the directions. So once after confirm everything, we just need to click OK, and then so once after everything confirmed, what we need to do is that we need to generate our operation plan, okay, right? So we still under the SolidWorks CAM feature tree. So this time, go to mill part setup 4, and then right click, and then what you need to do is that you just generate operation plan. Click this one. So it will generate the operation for us, right? And then uh, go to mill part again, part setup 4, okay, and now as you can see over here, they already switched to the SolidWorks CAM operation 3. Okay, so go to build path setup 4, right click, and then generate toolpath. Okay, so once after the path already generated, so this is the type of tools, cutting tools that we're going to use in order to create this particular of 3D part. However, we switch back to this one, the second tab. So the operation tab. So go to mill part setup 4, right click, and then this time we're going to simulate the toolpath. Okay, we're going to simulate the toolpath. So just pick this one over here, and this is what I mentioned to you just now, the stock that we have created previously. And for the navigation, we do have two types. One is tool mode, and another one is turbo mode. All right, turbo mode is the fast mode, whereas for tool mode, we will go step by step. Okay, the cutting operation, okay, will involve with step by step. Now, this is the speed of the simulations. Okay, the speed of the simulation. So I'm going to pick it somewhere around there. And this one is the section view. If you want to have a section view, however, in this particular case, I'm going to off this. And this is the stock shaded display. This is the stock. So uh, in this particular case, I can choose shaded with edges. And shaded with edges, or you also can use shaded display, or either one of these. So this I'm going to make it default as shaded display. Same to go with this one, tool shaded. Okay, this is the tool. Later on, we can see the tool. Okay, once we start with the CAM activities. All right. So tool holder shader. So all these I will, maintain it as a default. Okay, shaded with display and so forth. And as you can see over here, there's a collision. Okay, for tool pause on collision, if you click this one, so it means that if there's any collision, if there's any clash between the tools and also the materials, so it will automatically stop for us. The operation will automatically stop for us. Okay, sekiranya berlaku ada sebarang pelanggaran di antara mata alat, the cutting tools, dengan material, dengan stock ni nanti, dia akan automatically berhenti pause for us. Alright, so you may choose this one. Alright, so you can ignore collision. But in my point of view, it is much more better if you, more advisable for you to choose pause on collision. Why? Because if there's anything happen, if there's any collision or any clash between the, as I mentioned to just now, between the cutting tools as well as the stock or the raw materials, so we can know at which area that we need to do the troubleshoots. Okay, so now same to go with this one, tool shoulder shank. Okay, with this one, tool holder collision and so forth. So I just leave everything as a default, right? So this is to show the difference. Okay, so this is the difference in terms of the uh, thickness, the tolerance of the cutting thickness. All right, so let's say for the time being we off this one first, and then once everything is ready, just leave this one as well, this one. All right, so in the information, so just click run. There you are. So they will, you can rotate during operation, no problem. So okay, there's this is what I've told you just now. Okay, so rapid collision occurred in the operation rough mill 1. Okay, rough mill 1 between the tool and the stock. Okay, between the tool, this is the tool. Okay, this is the tool and the stock. Okay, I purposely secret for this one so that we can do the troubleshoot later. Never mind, we can proceed for the time being. We try to have a look, is there any other default or collision occur between the cutting tools as well as the material. Okay, all right. you can rotate your, this is the tooling, this is the holder, and this is the cutting tools. Okay, this is the cutting tool. All right, so now seems like we only face one problem, which is mill one. So in this particular case, okay, we need to go to the operation tree over here, and it's stated just now mill one. Okay, the contour mill one. Okay, the contour, not the rough mill. Is it the rough mill? I think we try both of these, but we need to check this one first. Go to here, right? Okay, mill one, which is stated over here, mill one. Right click and then edit definition. And okay, there you are. So these are the operation parameters dialog box, and as you can see over here, we do have few parameters. This is a roughing, okay, side parameters, depth parameters. However, normally all of this I will just let it as a default. I just would like to focus on tools. Normally, if there's a collision between the tools as well as the stock, okay, normally it related to the cutting diameter, so cut diameter. So I'm going to reduce it to 4 mm instead of 6. Let's say we try 4 mm, and then just click OK. And toolbar, okay, just add, right? And don't forget to right click and then generate toolpath again, because we already changed our parameters of the cutting tools. So generate toolpath and then go back to simulate toolpath. All right, so now we're going to check again. Okay, we need to go into check again. Okay, run. Okay, seems to like okay. So we already solved the collision problem just now. Okay, there you are. So just now the collision occurred over here, right? So you can have a full speed, right? But since I just would like to show to you, okay, how the step by step of this cutting tools. Okay, you can just simply create like that. All right, so now seems like it's okay. And if now we go to show difference, and as you can see over here, if the green color means that it's totally have a very nice cutting, because there's no differences. However, normally at fillet side, at ready side, uh, there will be a slight difference in terms of the tolerance. Okay, so as you can see over here, okay, normally it will happen like that, right? Because it's not some sort of a flat, it's a curvy shape. It's not a flat shape. So normally it will in simulation it will shows us there's a slight difference like this. So this one is still acceptable, no problem. So it means that everything is okay. Once after everything is okay, just need to click OK over here. All right. And then the next thing that we need to do is that I'm going to switch back to our isometric view. And the next thing that we need to do is that we need to, go to post process over here. Go to SolidWorks CAM and Manager, and then go to the post process. Okay, and let's say I'm going to go and find out just now the folder CAM tutorial, and I'm going to name it as file CAM pass part 1. Okay, post process. So I'm going to suppose you can rename it with any name, okay? So however, for my case, I just click this one. All right. So once after you click play, it will show to us or build for us all the G codes for the CNC over here. Okay, so just click this one. Okay, click this one. There you are. So all these are the G codes. All right, for the milling CNC operation in order to create this particular of component or parts. All right. So once I to confirm, just need to click OK. All right. And then another one. Okay, this is actually the. Okay, they will come to here, so should be no problem because this is the uh, codes as well mentioned just now, the G code as well as M codes in order to create the 3D solid modeling part, which is this one, by using CNC milling operations. All right. So the next thing, the last thing that you need to do is that you go to SolidWorks CAM and C Manager over here, right click, and then go to Setup Sheet and just generate it. And you can save it under the folder that you have created, so that it is much more easier for us to refer later on. So it will refer to this particular of folder, so no need for us to um, go and search everywhere. So we specify it with this particular of folder. So I'm going to save this sheet setup of this operation under the CAM tutorial. This is the folder we have created, and then just leave it like this, and then just click OK. Okay. So I will show to you later on how does it looks like. Okay, so this is automatically okay. Once after confirm, okay, we just need to go to the here. All right. So this is the file that where I already created and to CAM tutorial. This one, right? And then this is CAM part one. This is our part just now. Okay. So CAM part one. And as you can see over here, there's a CAM part one, which is SML document. So if you go to here, double click, this particular of sheet will, milling process sheet will appear. And this shows to us, okay, milling process sheet. Okay, this is the name of milling process sheets, whereby these sheets indicates the total time in order to fabricate or to create or to produce this particular of 3D solid modeling part with the CNC milling operation, which is 35.31 minutes. All right. And this is the machining time, okay, total machining time. All right. And all these are the operations that involve in order to create this particular of component or part. Okay, neglect about the setup number two because I accidentally just now only created another one more setup. That's why it's the machining, but won't involve anything. That's why the machining time is 0. Suppose that this one they don't have. Okay, they don't have. All right. So in this particular case, in order to create or produce this particular of 3D solid modeling parts, it involved with 5 operations altogether, which is rough, mostly rough, and contour. And even as you can see over here, this is actually the types of cutting tools that involve. Okay, this is the feed rate of each of these operation, the RPM, okay, the machining length. All right. Okay, this is the length in, I think this is in mm. All right. And this is the machining time. And as you can see over here, the most uh, machining time, okay, the highest machining time is the rough milling one. So this is actually some sort of like a summary in order to summarize all the operations that involve in order to create a certain 3D solid modeling part or 3D solid modeling component. Okay, guys. So this is known, again, I would like to inform you here that this is known as milling process sheet. right? Okay, so I'm going to close this, and this is mill operations. Mill operation. This is actually the operation. There's nothing much to do because this is only involved with the programming, right? So if we go to check the post process just now, which we have received just now, okay, post process, if you still remember, if you double click this one, okay, this is actually the G codes for the CNC milling operation. Okay, the codes that involve in order to create the the 3D parts, which we have already done just now, right? So this is the codes for the G codes, and this one, okay, is for the milling sheet, milling process sheet, right? So milling process sheet, this one, and also the codes, G codes. Okay. All right, guys. So I think that's all for now. Hopefully that you understand. If you don't understand, please, uh, you can refer back. You can scroll back, okay, to this video, okay. You can rewind this video and go through one by one, step by steps, okay, in order to understand the process or the concept of using the SolidWorks CAM simulation in SolidWorks. Okay, guys, thank you for your attention. Thank you for watching.